This is Josh White with JW Math Tutoring. In this video, I'm going to cover the ultimate Desmos guide to digital ACT math advanced skills. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Before I start this ACT math video, I just want to take a couple seconds and let you know about my Improve Your ACT Math Score course, available on both Udemy and Teachable. The course features a wide and comprehensive review of ACT math topics, including how to use both the TI-84 and Desmos graphing calculators. It also includes general strategies, such as back solving and picking numbers, and a review of topics in algebra, geometry, probability and statistics, and other miscellaneous topics as well. It includes over 10 hours of instructional videos and over 20 total hours of videos including solutions to various problems. So please check out that video if you're looking for more help on improving your ACT math score. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And let's go ahead and get started with this video. Welcome back to part 5 of my Ultimate Desmos Guide to Digital ACT Math. This video is going to cover some advanced skills, and I'm going to go through, talk about those specific operations that you're going to type in, and then go through example problems for each of them as well. Obviously, if you haven't done so already, check out the earlier videos in this guide, including the intermediate skills and the core skills, and of course, even the introduction to Desmos, because there might be some useful things in that video that you might not be aware of. All right, so before I go ahead and get started, just a reminder, the PDF files that have the instructions or the reference document that you see on the screen right now, there'll be a link to that in the description of the video, also in the pinned comment below the video, and same thing with the practice problems that we're going to go over as well. Okay. Oh, and last thing I want to mention too, I'm using the web version of the Desmos graphing calculator that is designed for the ACT. So the address of it is at the bottom of this video. That address, that specific version of Desmos is what you should use if you are practicing paper, ACT problems, okay, and wanting to use Desmos. All right, so with all that being said, the first topic we want to look at is finding the value of a constant or constants to match expressions using regression. So essentially what you're doing here is you have two different expressions and you're told that they are equal, and one of them, or possibly both, has a constant or multiple constants in them, and you're trying to figure out what the values of those constants have to be in order for the expressions to be equal. So what you're going to do is you're basically going to take either the equation that you're given or, say, the two expressions that you're given, which are equal, and you're going to type them all out, except instead of the equal sign, you're going to type a regression sign. For any x's, lowercase x's, you're going to type x with 1 subscript. If you have any y's, you would type y with a 1 subscript as well. And then after that, but this example, these instructions assume you only have expressions with x's in them. After that, you need to create what's called an element list for x1, okay? And this is basically where you define x1 as more than one number or as multiple values. You put them inside brackets and you separate them by commas. The reason you do this is because you're telling Desmos that you want Desmos to make these two expressions equal for all values of x. So regardless of what x is, you want these two things to be equal, and then you want it to find the values of a and b or c or whatever to make that true, okay? You do not want it to treat x1 as a constant. You want x1 is a variable, meaning x1 can be any number, and you still want the left side to equal the right side. That's why you have to include the element list. And related to that, if you do not include that, on some problems it will still work correctly and find the constant values, but on some problems it will not. It will find the wrong or incorrect values for your constants. All right, so with all that being said, let's go ahead and look at an example problem now. So I'm on the guide. I am at the top of page number 12. This is problem number 38. Basically, you have two rational expressions here that are being added, and you're told that they're equivalent to this other rational expression, and it's got some constants a and b in it. And it wants to know, okay, what's the value of a plus b? So what we can do is we can go to Desmos, and I can start typing the left side. Now I do have to remember to make every x into an x1. And then I'm going to put a tilde, and then on the right side I'm going to put what it is equal to, which is the ax plus b over, and then the two parentheses on the bottom. So let me now just spread that out. Okay, so notice it's giving me values for x1, a, and b. These a and b values are not correct. We'll see that in a second. For x1, your regression in general, for this type of problem, you do not want x1 to have a value in it. Okay? Because we're going to define x1 separately in the element list. If you are trying to do a regression problem of this kind and you have a value showing for x1, that means you're not typing the element list or you're not typing it correctly. So now what I'm going to do is I'm going to make my element list, and a couple things to be aware of. First, you need to have the number of items in it that is greater than or equal to the number of constants. In this problem, there are two constants, a and b, so I need at least two items in my element list. Second, you need to make sure that you do not use values in your element list which are restricted. So for example, in this problem, x cannot equal 1/3 or -5/2. The reason is because if you plug that in, either those values in, you would get a 0 in a denominator and the problem doesn't work. Okay, so you have to make sure you only use allowable values. Some problems also have domain restrictions where it says like x has to be greater than 1 or something, like that. So you just make sure that you pick values which are basically in the domain of the expressions. So notice I'm just going to pick 1 and 2. Very simple. Now I have the values of a plus b, and I can just do a plus b and get 2. So the correct answer for this problem is just going to be letter C. It is 2. Now, notice it technically, it did give me the correct value for a plus b when I did not have the element list, and it had them as 1 and 1. However, the individual values were not correct. So if this question only asked for like the value of a or the value of b, and you did not put the element list, you would have gotten the wrong answer. All right, a couple other things just to mention about the element list here. There are other ways you can do it too. First of all, you can obviously include more numbers. Notice that the values aren't changing. They're staying the 37, -35. You can also do this. You can do like a 1 ... and then put another number, and that'll technically fill in from say like 1 to 20, or 1 to 10. So rather than typing out 1 through 10, it's just, it's a quick way to do 1 through 10. And a third way you could do it is you could actually type random and then just pick whatever, 5. Here you don't need the brackets. The other things you do need the brackets. This just picks 5 random numbers. Usually they're decimals. And it will also work for this type of problem to find the values of the constants. So either of those three are acceptable. I mean, I personally just typically use, like 1, 2, 3, 4, 5, this method, but you can use any of those three methods for a problem like this. All right, so now let's go back to the guide. Let's talk about regression for other types of functions besides linear functions. So previously in the guide, we looked at linear regression, which is basically if you have 2 points on a line, it finds the equation, it finds the slope and the y-intercept, or if you have a point and a slope, linear regression will find basically the b value, the y-intercept value of that line. You can also use regression for exponential functions, logarithmic functions, rational functions, radical functions. I don't have it listed here because I don't think it's very common on the ACT. It's much more common on the SAT, but quadratic functions as well. So these are just general kind of generic forms that you see on the screen here, but in the problem itself, um, the specific variation of the function could differ, okay, depending on how it's set up. Also, the way what you're going to determine is either they're going to give you the general form in the description, text of the problem, or when you look at the answer choices, you can see the different forms that the functions are in. Last thing just to be aware of, um, the number of points that you're going to need to do the regression is going to need to be, again, greater than or equal to the number of constants in the function. So if you have 3 different constants, meaning 3 different coefficients or, whatever, constants, numerical constants, then you would need at least 3 points for the regression to work properly. So let's look at some examples now. Here we have question number 39. And here you have a graph of a function. I'm actually going to zoom in just to make it a little bit larger. You are given some equations for it. Now, one thing I do want to mention is a lot of you might find this problem faster or easier to do by graphing out the answer choices and then seeing which one matches the graph on screen. And that's fine. If you want to do it that way, that's basically matching equivalent expressions. Again, that was covered in an earlier video. I believe that's in the intermediate skills video. If you want to solve a problem like that using that approach, that's, again, totally fine, totally understandable. This is just to show you an alternate method, an alternate approach that you can use as well. So what I would do here is we're going to make a table, but now I need some points, okay? So I'm going to go here, and I'm going to notice, okay, I've got -2, 0. I've got 0, 3. And it looks like right here I've got 1, 7. Okay, so now I'm going to go to my table. I'm going to type in these 3 points. 7, 0, 3, -2, 0. Okay, now I have to do a manual regression statement because even though these are exponential functions, if you click this and go to exponential, like, notice this is not the same form because this doesn't have the constant added or subtracted at the end. So you can't use this. So I'm going to delete this, and I'm just going to type my own regression statement. I'm just going to do a times b to the x1 and then plus c to represent the number at the back. So notice, a is equal to 4, b is equal to 2, c is equal to -1. So we're looking for the graph that is 4 out front, 2 in the parentheses, not this, and -1 at the back. Therefore, it is letter C for this problem. Okay, and that's how you could use exponential regression to get the equation for this function that you're given the graph of. All right, now let's look at an example involving a rational function. So we're at the top of the next page. It's question number 40. Note that this graph is only part of the entire graph of the rational function. Like, sometimes they only show you part of the graph. They don't show you the full thing. So what I'm going to do here is, okay, notice most of these things have 2 constants. There's like a number on top, and then there's a number on the bottom, added or subtracted with the x. So first, let's just get rid of this. Let's create the table. So I'm going to need 2 points for this problem. So where do I have some points? Well, looks like there's one right here, -2, 4. Do I have any others? Yep, I've got 0, 2. Looks like there's also one over here at 4, 1. Again, we only need 2 of them, but I found 3, so we can just enter all 3 of them in. Okay, and now my general form looks like it's going to be, again, just to show you, if you click this, notice it doesn't even have a rational function regression as an option here. So again, this is one you would have to type manually. Y1 tilde. On the top, I'll just put A, And then on the bottom, I've got x1 plus, whatever, b. Okay, so I've got a as 8 and b as 4. So it's 8 on top. Well, they all have 8 on top. Okay, and on the bottom, it is x plus b. It's x plus 4. So it looks like the correct answer to this one is going to be letter A. And you could also just confirm this by just graphing this and note 8 over x plus 4 and notice that it overlaps. Again, for this problem, some people may prefer to solve it by matching equivalent expressions, which is to graph each answer choice and then see which graph on your Desmos screen matches the graph of the problem. So if you want to do this problem that way, again, completely understandable. That was covered in the intermediate skills video. All right, so next, let's talk about another advanced skill. This is solving a system of equations using regression. Okay, this can be used for any system equation. So you could solve a linear system of equations doing this, but you could also solve systems of equations where you have a linear function and a quadratic, or whatever you're given. The advantage to this is that it will return the exact value for the solution, for the intersection point. Okay, so if the intersection is difficult to find, or if it's some random decimal, it's not a nice integer value, and you need to use that decimal value in some calculation, this is very useful, because then you can just copy over like the x or y coordinate, whatever you find, and then it will, it'll give you the exact value. Use it for the calculation. So you're going to type two brackets with a tilde in the middle, and then on the left side, it's going to basically be the left side of the top equation, comma, bottom. And then in the right bracket, it's going to be the right side of the top equation, comma, the bottom one. One other thing just to note too, you may need to use restrictions sometimes on like x1 or y1 if it's giving you, if there are multiple solutions and it's giving you one that you don't want or doesn't meet the conditions of the problem. Like, let's say it's something that has two solutions, like a quadratic and a line intersecting, and it's, what is the smallest, or what is the positive, or what is the negative solution? And it's giving you the opposite. You would need to put in a restriction, like, which you can see on the screen here, x1 greater than 0, and you put this at the end in order to return the other solution. So let's look at an example problem now. Let me go back to the default zoom. We have question number 41 here. So this is a problem where you have basically a proportion, and there's two variables here, x and y. So this is an example of a problem that I specifically chose because, first of all, it's a very common problem type, and second of all, you can solve this so easily and quickly in Desmos. So what you're going to do is you're going to think about this problem as a system of equations where this is the top equation and this is the bottom equation. Think of it kind of separated like that. So top equation left, and the other thing too, just be aware, you do need to type x1 and y1 because we are doing regression. Bottom equation on the left, 3x1 plus y1. Now, top equation right, 5. Bottom equation right, 12. So it gives me so what's the value of x over y? So now I just do x1 over y1. Okay, these are all fractions. I mean, I should have some idea of which one it is, but let's just click this. Okay, it's 17 over 9. The correct answer is letter D, and that's it. That's how you can solve this problem in, under 30 seconds. Now, one thing, just to show you another example, there's no example problem here, but let me just show you an example that I'm going to graph out visually. Okay, here I have a quadratic function and a linear function, and they intersect at 2 points, right? So this system of equation has two solutions. All right, so let's just get rid of that temporarily. Let's say I wanted to solve this now. And so if they were given like this, well, you could say the top left is just y1 and the bottom left is just y1. Okay, and then the top right is 2x1, bottom right x1 squared plus 3x1 minus 7. Okay, so notice, right now by default, I'm going to turn this back on, it's giving me this solution right here. Notice 2.19258, 4.385, blah, blah. Okay, but let's say the problem asked for the negative solution, or the negative x-coordinate, or negative y-coordinate, or the smaller solution, however it was worded. So in other words, this is not the correct answer. This is not what the problem is asking for, even though it's a solution to the system. What you could do is you can put in a restriction, like say x1 less than 0, and now it returns the correct solution. And just write down here, notice these are the correct values that match up with x1 and with y1. Okay, so sometimes you might have to do that if the regression statement, and I mean, applies to any, equation or system equations being solved with regression. It's not specifically for, systems. It's for single equations as well. If it doesn't return the specific solution you are looking for. All right, so now let's go back to the guide. Next topic we want to talk about is solving advanced regression percentage problems using regression. This is something that's very common on the SAT, but generally has not been on the ACT until just recently. What you can do is basically, if you have these advanced percentage problems, which I'll show you an example of what I'm talking about in a minute, you can basically just make a system of equations, and then you can type it, put it into Desmos as a system of equations like we just did. And it'll solve it all for you, and everything should work out appropriately. And you can use the percentage sign in the system of equations. You don't need to like change anything or rearrange anything or so on. And notice it's like equation 1 left, comma, equation 2 left, comma, equation 3 left, and then all the right sides go, in the right brackets. All right, so let's look at an example problem. First one we have here is 42 at the bottom of the page. So we've got A, B, and C. All right, so what I'm going to do, this is just for demonstration purposes. So this is not what you would typically do if you were, once you are familiar with the skill and master it out and are solving the problem. Okay, so these are my three equations. So now, the equation 1 left side is just A. Equation 2 left side is just B. Equation 3 left side is C. So I've got A, comma, B, comma, C. All right, now on my right sides, I've got 235% of B, 3.4% of C for the second one, and P% of A. Now, notice it's not working. It's giving me all these triangles because of these up here. So as soon as I delete these three things, then it will work. Okay, so notice it automatically filled in and chose values for A, B, and C. Therefore, I have the value of P, and it says, what is the value of P rounded to the nearest whole number? So notice it is 1251.56. So the 5 immediately after the decimal will round the 1 up to a 2. So the correct answer for this one should be 1252. It is letter B, and that is how you can solve this problem entirely in Desmos. Now, I have another example here, question number 43. Similar, just the numbers are a little bit different. So the first one is A is equal to 626% of B. And now the second one is A is equal to 72% of C. And then the third equation, C is equal to P% of B. All right, what is the value of P to the nearest whole number? So for this one, we can see the correct answer is going to be letter C, 869, because the 4, immediately after the decimal place would keep the 869 as it is and not round up. So now let's go back to the guide just to talk about one last topic. So this is not something that I think is doesn't come up very often, but just in case it does, you can use the sum, notation to get the total sum of a bunch of numbers being added together. So you just type sum and then the blank, basically it's sigma, Greek letter, shows up, and then you would fill in basically on the bottom the number you're starting at, on the top the number you're ending at, and then for the formula it would be the number of values being summed. So, for example, you type sum, right, and it's like 1, let's just do a very basic example, 1 to 5, and your formula is going to be in terms of n here, right, because notice it's down here, it's n equals 1, n equals 5. So if you just do n, this is basically saying if you take 1, 2, 3, 4, 5, and you add them all up, you get 15. Now, you could also technically do odd and even numbers. If you wanted to do even numbers, you would make this 2n. But notice here, what you're actually adding is going to be, so for example, 2, and then when n equals 2, it makes 4, and then for 3, it would be 6, and then 8, and then 10. Because, when you go plug in 5, 5, you get 10. All right? And so you can just confirm, 10 plus 8, 18, 18 plus 6, 24, 24 plus 4, 28, 28 plus 2 is 30. Now, if you want to do the sum of odd values, odd integers, what you would use is the formula 2n minus 1. Okay? But notice here it is not giving us the answer we expect, because if you think about the, plugging in from n equals 1 to n equals 5, plug in n equals 1, 2 times 1 is 2, minus 1 is 1, and then 2 times 2 is 4, minus 1 is 3, and then 5, and then 7, and then 5 times 2 is 10, minus 1 is 9, okay? If we add these up, 4 plus 5, 9, 7, 16, plus 9, it should be 25. Why is it not 25? Why is it 29? Well, what's happening is it's treating this as like its own separate thing, and it's doing this, which is the sum of the evens we just saw, and then it's just taking 1 off that total. What you really need to do is you need to instead put the entire formula in parentheses. So for example, notice when I do this, now it gives me the correct value of 25. Okay, so if you want to do something with like adding up just odd integers, odd positive values, you could use this. You could use this formula. All right, so now let's go ahead and take a look at an example problem dealing with this. All right, so now here's an example problem where they tell you the sum of the first 10 positive integers is 55. What is the sum of the first 50 positive integers? So if you're going to use this Desmos method, this information right here is irrelevant. You don't need this in order to do the problem. All you would need to do is basically just, type sum. Okay, we want to know the first 50 integers, so we're going from 1 to 50 of n, and there's your answer, 1275. Now, obviously, there's a formula that you can use to do this as well. It's like the first value plus the last value divided by 2 times the number of integers times the number of values in your increasing sequence. But the point is, you don't need to memorize that. You don't need to do that when you can just go to Desmos and just type this all in and get the correct answer. So the correct answer for this one is going to be letter C. I hope you enjoyed this ACT math related video. If you did, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you're looking for more practice in improving your ACT math score, please check out my course, Improve Your ACT Math Score, on both Teachable and Udemy. There are direct links to the course on both sites listed in the description and pinned comment of the video. Otherwise, good luck as you're preparing for the ACT math test.